My name is Kisha Mudley. I am from Saudi Musgrave campus. My student number is 24328739. This is my Natural Science and Technology Information 102 Part A Practical. My aim is to test the household items for acidity, basicity, and to show a neutralization reaction. Now, safety first. My hair is tied up in a bun. I am wearing gloves, a long sleeve shirt for splash protection, a kitchen apron that is tied around my neck and waist. I have old newspaper under the workspace. The safety poster behind me recommends goggles and a lab coat. I will keep the liquids away from my face and clean spills immediately. So, a bit of a disclosure, for safety and consistency, I prepare the test liquids ahead of filming and have already poured them into the label cups. During the video, I will only add the red cabbage indicator to each of the label cups. The neutralization demonstration will be filmed during this video. So, materials and measurements. Materials, the red cabbage indicator, 7 label plastic cups, vinegar, lemon juice, milk, bicarbonate soda, dishwashing liquid, I use sunlight liquid, which is pre-diluted, toothpaste, pre-diluted, and water. This will be my neutralization, which is I will do in 1 cup. I use 20 milliliter indicator per cup. Samples were pre-poured, acids are neutral, 5 milliliters diluted bases, 10 milliliters. Now, the indication for preparation, I prepared the red cabbage indicator by blending the red cabbage with 250 milliliters of water in a NutriBullet blender and then straining the purple liquid into a clean glass. This purple solution is my pH indicator. It changes color depending on the acidity or basicity. For testing each cup, I'll use my red cabbage indicator pH color chart. Now, I will expect vinegar and each of the rest of the 7 cups to turn a certain color. I will first start with the vinegar. I will pour about 20 milliliters of my red cabbage indicator solution. I pour 20 milliliters of my cabbage juice indicator into a medicine cup to get exactly 20 milliliters. Now I expect the vinegar to turn pink or red, indicating acid. Now let's pour it. Using our chart, we will determine whether it is an acid or a base. Now, from the colors spectrum shown here, I will determine it to be pH 3. I expected it to be either pink or red. Use the lemon juice. I expect the lemon juice to turn pink or red, indicating an acid. Showing over here, I see a bit of a pink color that matches into a. So that is the pH 2 showing an acid. Milk. I expect my milk to turn a light purple pink, indicating a weak acid. Going over here, I observed it turned a weak purple, showing it to be an acid. Next, this was prepared earlier by dissolving 1/4 teaspoon of bicarbonate soda in 10 milliliters of water. I expect it to turn blue or green, indicating basic. Seeing on the chart, I see it's a pH 7, showing I have observed it to turn blue, indicating basic or basis. Next, I will use my pre-diluted dishwashing liquid. I had 1 teaspoon of dish soap, plus 10 milliliters of water. I expect it to turn blue or green, indicating basicity. Using the chart, I can see it turned to navy blue, pH 6. Next, I will use my toothpaste and water. So I used pre-diluted it before the foaming. I used a pea-sized blob of toothpaste and added 10 milliliters of water. I expect a bit of a bluish green basicity. Looking here, I can see it turned to pH 7, blue color. I observed it to be blue color, indicating basicity. Next, I have my water. So I expect my water to remain purple or blue, indicating it to be neutral. Using my chart, I can see that it turned purple. It remained the same, indicating it to be neutral, pH 6. So now let me show you each one of them. That's how it turned out. So we started with the vinegar and we expected it to... So now that we finished all the mixture and adding our pH color solution indicator, notice the color gradient from pink to red for acids, through purple for neutral, to blue to green for bases. This is my separate... Okay, so looking at the chart, you would see the different indication of each of the pH color, indicating whether it's an acid, base, or it's neutral. Acidity, the basicity, and the neutral. We had expected the vinegar to turn either pink or red. It turned a bit of both, a mixture of red and pink in between. The lemon juice, we expected it to turn pink or red. It turned dark pink-like color. We expected the milk to turn a purple, light purple color. We got that. Bicarbonate soda, which we had already mixed with water before this, we expected it to turn a blue-green color. We got a dark blue color. For the dishwater one, we expected the dish soap, we expected to turn a navy blue-like color or just normal blue-green mixed color. We've got that. The toothpaste, we expected it to turn into bluish green. We've got that. And for the water, we expected it to remain purple or blue, and we got that. Neutral, we've got it to turn neutral, basicity, 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 and our acidity basis here. So these three are our acids, these three are our basicity, and this is our neutral. This final cup is my neutralization demonstration cup. It was prepared earlier by mixing vinegar and bicarbonate soda together, which caused fizzing as carbon dioxide gas was released. Now that the reaction has settled, I'll add 20 milliliters of red cabbage indicator to this cup. You can see that the color stays close to a purple blue-like color, showing that the mixture has become neutral. This demonstrates that the acid and the base reacted to form a neutral solution. This chemical equation is acetic acid plus sodium bicarbonate yields sodium acetate water and carbon dioxide gas. Now, our explanation would be acids donate hydrogen ions and bases accept them. The red cabbage pigment changes color depending on the hydrogen ion concentration. That's the pH. Neutralization combines hydrogen ions and hydrogen ions to form water. Possible errors include uneven measurements, lighting differences, or slight variation in indicator strength. Improvements could include using pH meter or equal light conditions. And for safety, we wear goggles, a lab coat if available, and keep liquids away from your face. This type of neutralization is used in real life, for example, in anticides that neutralization stomach acid and in farming to correct soil pH. Thank you. This completes Part A for Natural Science and Technology Information 102 experiment.